Now let's look at a couple of IP addressing services. The two of them that we're going to talk about today, I think there's like two we'll look at. Domain name service and DHCP. The domain name service basically converts the URL into an IP address. I don't know about you, I can probably remember Cisco.com a whole lot better than I can remember 198.133.219.35. Actually, I'm mistake, it's 25. But, so DNS translates that between a name and an address. So when you look at the sequence of activities that's going through, I'm typing in, you type in a fully qualified domain name, FQDN. So what's that? That's the www.cisco.com. That's a fully qualified name. Now from that fully, you put that into the address field in your browser. What happens is the system does a DNS query. It says, okay, I've got this URL. Can somebody figure out what its IP address is? So it creates a DNS query and sends it up to a DNS server. There are servers on the system that are identified to store these IP addresses so that we don't have to store each one individually. So with that fully qualified domain name to the server, I end up making a request to say, send me the address. So it gives me, once that DNS server gets that fully qualified domain name, it matches that up to an IP address and then returns that IP address to you. So just letting you know, so you made the request, you got a URL, you don't know what the IP address is, you send it to the DNS server, it goes through its tables and then sends a, hey, I found it, and then sends back a DNS query response with that address. So you're kind of looking at this address here. It's like, and now that I've got an IP address, now what can I do? I can now go down to the Cisco service and get the address I want. Now, to do this, it's more than just one server that's doing this. There's a whole lot of information behind the scenes. So the first thing is, what is the message format? The DNS server stores different types of resource records that are used to resolve that name. It doesn't just, there isn't just one server out there that stores every IP address in the world and gets this. So what it does is it identifies, organizes this system, all the IP addresses into different categories so that it's easier to just organize and keep track of and take, update changes. Now, because it stores different types of records, these records contain the name, address, and type of record. Some of these types of records they listed, whether it's an A, it says it's an N device, an IP4 address. Maybe it's a name server, so it's an authoritative name server. Maybe it could be an N device for an IPv6 device, where it's a quad A. Or it could be a mail exchange, MX. So it's just some of the types of different records that can happen. If you're on your computer, on your PC, if you type in ipconfig/display DNS, you can see all of the saved DNS entries, because your computer doesn't want to go back and do this search every single time. It wants to do things as quickly and fast as possible, so it stores some things locally so it doesn't have to make a request to the DNS server, because that DNS takes time, not a lot, but it takes some time, and we're basically lazy and don't like to do this. But we also, not only with different types of records that are stored, there's a hierarchy in the different servers. And we've seen this where you get different top-level domains represent different types of either countries or businesses. The ones we're used to is .com or .org, or .edu. So they've classified certain top-level domains to help it be a little bit easier to filter through information, so that when you're making a request, because I can't store every college IP address on one server, but now if I put an edu, take all of those and put them under the edu server, maybe I don't have to confuse businesses with edus. But sometimes it's still a lot of information. So you may get a second level domain, where then it's broken down to maybe Cisco's got multiple different types of servers that it wants to use. So you've got the root level domain, which is just the top level of DNS, the top level domain where they're breaking down into different categories, and then a second level domain where a particular company or school can break it down into multiple different categories. So just keep in mind that this DNS is several servers with a specific organization that are storing records of different types, so that you know information about that IP address that's being returned. Now, on your computer, there is an NS lookup command, which can give you what is, to basically say, hey, what is you type in a command, say, what am I looking for, which address am I looking for, and it'll return an IP address. So it may be beneficial if you're just looking for an address other than teaching this class or showing the lab professionally. I don't think I've ever used the NS lookup command, but it's there. And I go ahead and play with the simulator, the checker, just to make sure you understand a little bit of that. Now, the last other service is the DHCP. Now, the DHCP is an IPv4 service that just automatically assigns IPv4 addresses, also referred to as dynamic addressing. So that way I'm not statically assigning addresses to every single computer, because if something changes, I don't want to have to go around in the middle of the night changing IP addresses and everything. So most companies will use a DHCP server, which you configure a pool of addresses, give it a range, a start and a finish address range in this pool, and DHCP assigns, or basically leases, that address to you for a specific time. And you can specify when you're setting up this pool how long or short of interval you want to assess, let them have access to that IP address. So when you tell it, I want to I'll lease it to you for a day, that time period is called the lease period. But like I said, for most servers, most of us will use DHCP only because it's easy. Now, DHCP for IPv6 is similar, but the difference is it doesn't provide a default gateway address. So you just want to keep that in mind. DHCP from IPv4 gives you IP address, subnet mask, default gateway, all of that stuff, DNS server information. DHCP, it allows the DHCP router to advertise that information, so the server doesn't have to handle it. Now the question is how do I get information? When your computer first turns on, how does it get this address? Well, there's a process. When you first turn your PC on, you send out a DHCP discover message. So you get DHCP discover, then the server sends back an offer, then you send back a request, and then you get an acknowledgement back. I guess the way I remember this when I first learned it was at the time I think Dora the Explorer was a key movie, but it kind of worked. Dora, discover, offer, request, acknowledgement. So it's those four sequences, that conversation, that four-way handoff between the client and the server, making sure that this information takes place. So just take a look at that and go through. I won't assign any addresses there, and I think I've gone long enough. I'll cover up file services. Let me go one more. It'll be a longer video, but file services. Now, basically, what is this? File sharing. That means I've got a server that has information on it that I want to share between a PC. Now, there is, in the file transfer protocol, you notice that there was 2 port numbers with that. You had 1 for control, 1 for data. So when you're looking at what happens is when you first make a connection, you use the TCP port number 21 that starts sending connection, response, control information. And then once that's set up, a second port is then established, and the data is transferred on port 20. So control on 21, data on 20, to make sure that that happens. Data can be transferred in both directions, doesn't make any difference. A client can pull down information, or a client can push data to the server. So just keep in mind, the biggest thing here is knowing that data is transported, it's TCP protocol on port 20, that's where the data is. The control information is TCP port 21. One of the things that can get shared is a server message block. And basically describes a server message block is structured of shared network resources, directories, files, printers, serial ports, things of that nature. So their basic functions for these blocks: they start and authenticate and terminate the sessions, they control file and printer access, and they allow the application to send and read information to or from another device. This server message block services have become mainstay of Microsoft networking, introduced back with Windows 2000, but Microsoft has changed the underlying structure, but it, for non-TCP/IP protocol. So I don't see a lot of that used, but just know it's out there. You may get asked. I don't think so. Just give you a rough idea how to copy and share information between your. So, rough idea. The biggest thing is FTP and the different port numbers. Keep those in mind. And with that, I think that is all the lecture I'm going to do for this chapter, for this module. So hopefully that gives you enough information. And if not, let me know. Talk to you later.